Assalamu alaikum wa rahmatullahi wa barakatuh. This is Mr. Abdinasir. I will be taking you through a question on rates of a reaction. Rates of a reaction, as you know, is speed in which a chemical reaction occurs per unit time. So here we have the question. It says nitrogen 2 oxide readily reacts with oxygen to form nitrogen 4 oxide. So the reaction that's taking place there is nitrogen 2 oxide plus oxygen gas leading to formation of nitrogen 4 oxide. Now that reaction, if it is represented on an energy level diagram, this is how it will look like. So when you are drawing an energy level diagram, here you have energy in kilojoule per mole, while here you have a reaction path, the steps in which that chemical reaction will involve. Now on the reactant, you have nitrogen 2 oxide gas reacting with oxygen gas. Don't worry about this half, is for balancing purpose. Now here we have an energy change. Here we have an energy change. You look here, when reactants are at the initial state, for them to react successfully, then there must be a minimum amount of energy that has to be provided with to bring this reactant up the hill. Now when they are at here, they are called transition state, and then the reaction now will continue until a product is formed. Therefore, here now we have the first question that asks, what does enthalpy change 1, enthalpy change 2, and enthalpy change 3 represent? Look at enthalpy change 1. What do you think it represents? That is from the reactant up to the transition state. Then that energy change, you should know that is activation energy. That is activation energy, the minimum amount of energy required to start a reaction. Then when now reactants are at the transition state, for them to form now a product, then that is enthalpy change 2, and that enthalpy change 2 is also activation energy, The question is, what is the difference between the enthalpy change 1 and enthalpy change 2? The difference is that this activation energy is that of the reactants, while enthalpy change 2 is that of products. That is the difference that you come to know. While enthalpy change 3, look at the enthalpy change 3, from the reactant directly, without being involved the activation energy to the product, then that enthalpy change, we call it heat of reaction. That is, a reaction of nitrogen 2 oxide will lead to, a reaction of nitrogen 2 oxide with oxygen will lead to formation of nitrogen 4 oxide. Hence, that enthalpy change is what you call heat of reaction. Now, what is the sign? What is the sign on enthalpy change 3? What is the sign of enthalpy change 3? Heat of a reaction of nitrogen 2 oxide with oxygen gas leading to formation of nitrogen 4 oxide, then the sign is either positive or negative. Therefore, that sign is a negative. How do I know? Because heat of a reaction that involves burning of nitrogen 2 oxide in excess oxygen, then that is exothermic reaction. And you note that exothermic reaction has a sign of a negative. That is good. Now, the last equation now, you are told write an expression for enthalpy change 3 in terms of enthalpy change 1 and 2. Look at our enthalpy change 3. Where does it fall? Now, for you to get enthalpy change 3, then it means enthalpy change 2 minus enthalpy change 1. For you to get enthalpy change 3, then it means this total energy, that is activation energy for the product, minus this enthalpy change, which is activation energy for the reactant. They have an expression for that. It will be that is enthalpy change 3 should be equal to enthalpy change 2 minus enthalpy change 1. And that is the end of our discussion for today on rates of a reaction on activation energy. Thank you for listening, and bye-bye.